Hello everybody, today I'm going to talk about APT MPX and we will see the keys of a good optimized FM broadcasting chain. So let's go with this presentation. It will take us about 30 minutes. My name is Greg Mercier and I am working at WorldCast Systems as a product marketing director. Let's go with this presentation. First of all, just to introduce quickly WorldCast Systems. WorldCast Systems is a company selling worldwide a couple of solutions for radio and media in general. There are three brands: APT for the transport of the content over IP, ICRISO focusing on FM transmitters, and Odemat, which is our brand for signal monitoring, test and measurement for FM, for DAB, and more. To collect all the data and monitor our devices, but also any kind of equipment, we use Kibio, our NMS, and this is globally what we can provide. But let's go with the presentation quickly. So first of all, let's start with the FM broadcast chain as a very basic statement to start with. Usually the FM broadcast chain is built with a studio which is providing the audio content. Then we will transport this content usually over IP. At least in this presentation we will take the case of an IP network transport, and then we will receive this content on the transmitter side and we will broadcast it with an antenna, with an FM antenna to the listeners. Okay, so this is the very basic scheme for an FM broadcast chain, but let's go more in detail about all the equipment involved in such a chain usually. So if we look more in detail, we see that the studio output needs to be processed. So we have a sound processor here at the studio to give the sonic signature of this radio and probably also to add a little bit of loudness to your content. Then we will use an IP codec. This IP codec is basically an encoder usually, and it will convert the audio signal into IP stream that we will transport to the transmitter site. So now on the right side, what we get is an IP codec again, which it's a decoder in this case. The decoder will feed a sound processor. This processor can be a big processor or a small processor. It will depend on the chain, but usually we will process again the audio because during the transport there may be always some differences. So in the audio. So we will always process again this audio here at the transmitter site. It will feed a stereo encoder to build the MPX signal or composite signal. We will add RDS to display the name of the station on the receivers, and we will send this to the FM modulator with one or several amplifiers depending on the power of your transmitter. And this is the signal that we will send to the listeners over RF. Okay, so this is the very basic traditional chain, and we will see how to optimize this in this presentation. So before optimizing this chain, it's important to note three objectives, three main goals that we have when optimizing this chain. The first point is to stay on air 24 hours, 7 days. Radio is a key broadcasting tool, and we want this to be on air all the time. So when optimizing the chain, we will think about redundancy, we will think about reliability of the chain. Okay. Second point is the sound quality. We want our listeners to get a great audio, and we want the broadcasting chain to be as transparent as possible, not to affect or not to add noise to our station. We want listeners to have the best quality possible. And of course at the best price, because we want to reduce our cost, and cost is always an issue for an FM station. So let's see how to optimize this. To stay on air 24 hours, 7 days, What we will do is to, first of all, remove the point of failures. Any equipment that can be a point of failure in our chain is an issue, basically. So we will try to reduce the number of components, reduce the quantity of hardware, and we will simplify, streamline our chain. The more simple, the easiest to maintain, and the more reliable it could be also. We will also add redundancy for the key elements if we cannot remove components because they are required, but they are a point of failure. We can use redundancy. And of course, we want to monitor the system, and we want to notify the right person in case of failure so that we can correct it as soon as possible. For the second point about the sound quality, one important statement I would like to make here and to keep in mind is that the quality of your FM station is always lower than the quality of its weakest element. So whatever the price you spend in the console or any sound processor or whatever, if you have one weak point in the chain, the quality will be that of this weakest point. So it's important to consider all elements and to work through all the FM chain. That's why we want to simplify the chain. We want to limit the operations on the signal. We want to check and measure the transparency at each stage. And we want to control and to standardize the equipment base, because we want the FM station to be received with the same quality over different transmitter sites across the country, for example. Third point, at the best price. Of course, we want to reduce the cost. Here, one very important point that you may already know. It is not only about purchasing price, but also about operating costs that are usually more expensive than the purchasing price, actually. So you need to look at the installation cost, the cooling, the power consumption, the IP bandwidth, the lifespan of the component, and also the support and the maintenance. One basic rule that we will use for this presentation today is to use less hardware and more software. So first, we will look at the easiest optimizations we can do in the chain. Today at WorldCast, we have a digital modulator since now more than 10 years. And this digital modulator allows better signal quality. It removes processing stages, so more operations on the signal are done in the single chip. And we can add built-in software features. This is a great advantage for many reasons, and also the key point is that increasing the number of features or having built-in features is done by software. So the reliability of the chain is increased actually because we use less components. So let's take our broadcasting chain and let's have a look. This is the chain as we described just before, and if we improve it by removing all the separate equipment by a single EXO-FM IO series transmitter, we see that all the features that we had previously in separate equipment are now integrated as a software inside the digital modulator of our EXO-FM transmitter. So here in this transmitter today, we can have an IP decoder, we can have a sound processor, a stereo encoder, an RDS encoder, and of course the FM modulator, which is actually using and providing all those features. Okay, so this transmitter today is a great evolution because the input is IP and we go directly to RF, direct to frequency. This will increase the reliability, the signal quality, and of course the cost also. Let's talk about now the different kind of chain we can use today. Usually we transport the audio to the transmitter side, but we can also use MPX-over-IP, which is a bigger challenge, but which is possible today. So this is a chain with audio over IP transport. So with audio over IP transport, what we need to use is a pair of codecs at the encoder and the decoder side, and the decoder will provide audio to the sound processor, the stereo encoder. That can be an EQRISO FM transmitter or any transmitter with a sound processor inside. Now, if we switch that to MPX, the difference is that the codec must be MPX compatible. And at the transmitter site, we will remove a lot of stages. We will remove the sound processor because it's not audio anymore, it's directly MPX composite signal. We will remove also the stereo encoder. The stereo encoder is now at the studio, not anymore at the transmitter site. Okay. The benefits of such solution is an easier signal standardization across multiple sites. There are less configuration to be done at the site. Everything is more at the studio, actually, because we have the sound processor and the stereo encoder at the studio in this case. Also, we have a better signal control and management from the studio and significant economy of scale because all the features that are multiplied by the number of sites are now at the studio in a single operation. So in terms of cost, it may be interesting, depending on your network, of course. A few drawbacks that we will need to figure out, or challenges at least. The MPX signal needs high IP bandwidth compared to audio. The MPX signal is more sensible compared to audio, compress or when we transport it. And we need to figure out the resilience to packet loss. Losing a packet of audio is an issue. Losing a packet of MPX signal can be more tricky. So we need to face these challenges. To do that, we will use APT-MPX. APT-MPX is MPX compression algorithm. Okay, a compression algorithm is what you know as MP3, for example, for the audio, which is the very famous compression algorithm for consumers. For audio over IP, for FM, usually we use better quality compression algorithms such as enhanced aptX. Well, for MPX, we will use APT-MPX. Okay, APT-MPX allows to reduce the bit rate that you need for the transport of your MPX signal. Linear MPX signal will take usually between 2 or even 3 megabits per second, which is so you need a big IP connection to do that, and especially if you have multiple programs. With APT-MPX, you can reduce that to 300, 400, or 600 kilobit per second only, and with a very high quality. Let's talk about quality. APT-MPX provide transparent sound, so nobody can hear the difference between linear and APT-MPX compressed audio. It is very transparent in terms of audio for the listeners, but also if you look at the signal itself. And it is very important because you want to keep all the characteristics of your MPX signal, deviation, subcarriers, and so on. The algorithm to perform that is based on a predictive method instead of psychoacoustic, meaning that no information is basically lost when using this compression. So the quality remains very high, and this is what makes the difference between this algorithm and competitors' algorithm that you can find on the market today. If you want to go further, I invite you to visit this site, our website, /APT-MPX, where you actually can listen to several audio content in linear and with APT-MPX compression. So you can see yourself the result, okay? Another point we mentioned before is the resilience to packet loss. APT-MPX has no keyframe in the stream, meaning that if you lose a packet, you will lose only the audio content that correspond to that packet and no more. Other algorithms based on keyframes will lose several hundreds of milliseconds of audio when losing this keyframe, because the keyframe allows decoding all the packets following that keyframe. Okay, APT-MPX is not based on this method. Each packet is individual and independent, so you will lose only the time of this packet, which is so small that nobody can hear it when losing a packet, and this is a very big advantage. Also, when a packet is lost, it is replaced by the algorithm automatically, so this reduces the impact of for the listeners. The deviation is kept also under control, but we don't use methods such as Clipper or things like that. We keep the sound of your processor and your stereo encoder, which is at the studio. Okay, so we are not adding clipping methods or things like that. APT-MPX is totally transparent, but keep the deviation as is from the studio. At the end, there is minimal, if any, audible impact in case of packet loss. We also have technology since many years called SureStream, developed by APT, and this technology allows packet redundancy over one or several IP links. As you can see in the scheme here, in the diagram you see we can use several IP lines, and if a packet is lost on one line, it is taken on the other one. So at the end, you have a perfect stream, even if your two lines are imperfect. APT-MPX also provide low latency. It is very low in terms of resource consumption, and this allows also cross-platform compatibility. So we can embed APT-MPX very easily into all our platforms, APT codecs, but also our Expresso FM transmitters, or also other platforms from other manufacturers that who want to embed APT-MPX in their device. Let's have a look now to virtualization. This is also a key point today when we want to optimize the FM chain. To start with, let's see the hardware solution, okay, with MPX and APT-MPX. This is the chain with APT-MPX transport over IP from the studio to the transmitter site, and we use only hardware devices. If we want to replace this by software, let's start with the transmitter site. We will replace the codec, RDS encoder by the Expresso FM IO series and its software features. So the IP codec here is a software module, and the RDS encoder also, okay, with APT-MPX, of course. So what we did here, it's not about virtualization as such, but we just replaced hardware by software at the transmitter site. This is the easiest optimization you can do today, because it doesn't require any knowledge or any specific installation skills. You just configure the transmitter and that's it. Okay. Let's go now further. If we talk about the studio, some processors recently provide their solutions as a hardware, but also as a software. This is the case, for example, here of Omnia 9S, okay, available now as a software, but there are several companies providing software on processor. We can talk about Orban, we can talk about Wheatstone, or any brand, basically, providing this kind of solutions. Today, what we will do is, in this case, is to add our APT-MPX software module at the end of this software sound processor to feed your transmitter site. Let's have a look. Here at the studio, you can see we will have, for example, a Windows platform, a Windows server, where you can install your software sound processor, which includes usually a stereo encoder, and the APT-MPX software that we just launched a year ago, and this will stream the content directly to the Expresso FM IO series or the codecs. Okay. This is what we did recently with a radio here in France that I like to take as an example, which is called Radio 100%. It's a case study of a modern and retro-compatible solution. What they did is to replace their old transmitter and old codecs and also sound processor by a fully software-based chain. At the studio, they use a sound processor, and we add the APT MPX software in the same server. They took the APT MPX signal through IP to their different links, and they feed the transmitters. They have several transmitters, actually. We are talking about 50 frequencies, and so they are not replacing all the transmitters today. They replace only few transmitters by the new Equrezo FM-IO series, directly decoding the APT MPX signal to RF. But when they have an old transmitter that they don't want to replace immediately, they still use the APT IP codec to decode the APT MPX signal and to feed their transmitter, or the silver version also. The silver version is a very interesting device because it is small, it is very competitive, it is more competitive than most units on the market today. It has MPX analog output, so it's perfect for old FM transmitters compatibility. The device is, of course, internally fully digital. It supports ShareStream and APT MPX. So very interesting to go from hardware to software in the future, okay, or when you want. So that's basically the chain that we did. As I said, they have 50 frequencies, but also 16 programs because they are doing a lot of local content in the south of France. And for this reason, because there are 16 output from the studio, 16 programs, we wanted to have something more complete, more professional in terms of virtualization. Not only a software, but something more robust. So what we did is to use the APT IP codec in its virtual version. Okay, so this is where we can have several codecs into the same server. In this case, we have a Linux server where each codec is in its own Docker container, and we use Kibio, our NMS, to manage the entire system. So this is the basic virtual APT IP codec solution. If you have multiple programs, it's really perfect. And if you have a lot of programs and you want to go further in terms of redundancy, we are also compatible with solutions like high availability HA, which allow you having 3 or more Linux servers fully redundant in a cluster. The codecs are then distributed across the 3 servers. In case of hardware failure of one of the servers, the codec is automatically deployed in the other servers with the same IP, same configuration, everything. Okay, this is a very powerful solution if you are running a lot of programs or if you need to transport or encode or decode several programs at the studio or at the transmitter site also if needed. Kibio again will manage the NMS, will manage the entire system and provide you the full vision of the system, of your program, and you can also monitor additional units such as the transmitter site, for example. This virtual APT IP codec solution has several benefits. As you can see, there are a lot of savings because the cost per codec is much lower. The service availability with solutions such as high availability and also the removal of hardware is a key benefit. It is scalable. It's very easy to add codecs in the future. And it is compatible. There is retro compatibility with your current network because we can encode with a virtual APT-IP codec, but we can decode with the hardware if we want. So it's very easy to deploy and to do a progressive migration from hardware to software. Thank you very much for listening to this presentation. I would be very happy to answer your question if any. You have my email here written in this slide, and don't hesitate to contact us also at worldcastsystems.com. There is a lot of information here, and you can contact us. We will be very happy to talk about your project or answer any question about our product and technologies. Thank you very much again. Bye-bye.